All right, let's get into it. We've done rounding before. We did rounding as we went through our chapter on geometry, but in a chapter on consumer math, we're going to be doing a lot of problems that involve money, dollars and cents. And because of that, rounding is going to be really important in this chapter. And so I want to make sure to take a little bit of time to make sure we're all very comfortable with rounding before we go forward in chapter 2. And so just a little refresher, just a little reminder, if we wanted to round 14.261 to the nearest tenth, the first thing we would do is identify the tenths place. That's where the 2 is, one space past the decimal. And so we'll find the tenths place, we'll look one space to the right. If the number in this position is 5 or bigger, we're going to round up to 14.3. If that number in this spot had been 4 or lower, we would round down to 14.2. And essentially the philosophy of rounding is, which is 4.26 closer to? Is it closer to 14.23? Or is it closer to 14.2 or 14.3? And because the number in this position is 5 or bigger, we round up to 14.3. With the one on the bottom half of the page, round 14.261 to the nearest hundredth. So now we have to find the hundredths place. That one's going to be really important for us in this chapter because there are 100 cents in the dollar. So rounding to the nearest hundredth is going to be really common for us. The hundredth is 2 places past the decimal. So we identify that. Just looking right there, we can see we're going to round down to 14.26 or up to 14.27. And the way we decide is by looking one space to the right. If that's 4 or lower, we round down. So we round this down to 14.26. Converting between decimals and percents. This is something that'll be really important for us to do in this chapter, going back and forth between decimals and percents. And I'm actually going to start this discussion with a fraction, and that fraction is going to be 1/2. If we wanted to write 1/2 as a decimal, we could write 0.5, or even just with the same value, 0.50. That has the same value as 0.5. Those two are exactly the same as each other. Either one would be considered correct if 0.5 were the answer to a question. And so if I can write 1/2 as 0.5, well, we'll talk probability later in chapter 4, but if something happened half of the time, what percent would that be? You know, when we flip a coin and half the time it comes up heads, what would we say? What percent of the time does it come up heads? If it happens half the time, what percent is that? Perfect, Ashley. Thank you. 50%. And so what we can see here then is that 0.5 and 50% are the same as each other. If I want to convert back and forth between decimals and percents, I can just kind of latch onto this in my brain. If I just kind of walk around with the idea, well, 0.5 is 50%, then I can remember how to go back and forth between percents and decimals. The thing that you'll probably memorize without too much trouble is if we want to turn a decimal into a percent, we're going to move the decimal point 2 places to the right. If we want to turn a percent into a decimal, we're going to move the decimal point 2 places to the left. And that's how we're going to convert back and forth between decimals and percents. But you know, if you ever find yourself kind of stuck in one and you're thinking, how do I do that again? This is a great place to lean back into. 0.50 is the same as 50%. And oh, okay, now I see how the decimal moves. That can be a good way to remember it. Let's say we wanted to convert 0.27 to a percent. So I want to turn this decimal into a percent. Now, there's a couple different ways to think of this. One of them is moving the decimal point, like we just talked about. If I want to convert this decimal to a percent, well, 0.27, I move a decimal point over, and that's 27%. And that works great. If that's comfortable for you and you're going to remember 0.27 is 27%, then that's fantastic. Another way to think of this, if you want to, is if you think about what this decimal means. This 0.27, that goes out to the hundredths place. So that is 27 hundredths. If we look at this, what that decimal means is it's 27 hundredths. And the word percent means per 100. Percent is per 100. And so 27 hundredths, that's 27 per 100, that's 27%. And so that's how those things all sort of relate to one another. Most of you will probably just move the decimal 2 places, and that's totally fine. But just to sort of understand where it's coming from, it's 27 hundredths, which is 27%. If we wanted to convert 34% to a decimal, 34% to a decimal, you have a couple of ways to go here. Probably the most common is going to be, well, I'll move the decimal point 2 places, and that's 0.34, and that's totally correct and totally fine. Another way you can convert percents to decimals is keeping in mind that percent means per 100. If we take 34 and divide it by 100, we'll get the decimal that we're trying to convert to. So if you have 34%, you could rewrite that as 34 over 100. Actually divide it on a calculator. 34 divided by 100, and you'll get the decimal that you're trying to convert to. Like I said, most of you will probably just move the decimal point 2 places, but if thinking of it a different way works better for you, then that's completely fine. Are there any questions on that before I have you try one? Okay. I'll set up a poll for this one. I want you to convert 4% to a decimal. Be careful. Not as easy as it may first appear. Convert 4% to a decimal. And there's a lot of different ways you can think of this, but make sure you're careful with it. We'll go another, let's say 20 seconds, and then talk through it. All right, let's see where we are on this one. Not unanimous, but strong agreement. That's kind of where we usually live. So let's talk through this, and you let me know if you have questions when we do. So we're converting 4% to a decimal. A couple of different ways you can look at this. It's 4%, and so if we just want to move the decimal point 2 places, we can do that, and we'll have 0.04, and that's got it. Or if you wanted to just, because we're converting a percent to a decimal, you could do 4 divided by 100 on your calculator and end up with 0.04. The big danger here is wanting to call it 0.4. But remember, if we use 0.4, what we're saying there is Well, to the hundreds place, that would be 40. That is actually 40%, not 4%. And we don't want that. So when you have a single digit or a really small number like that, make sure you're careful about including this 0, remembering that percent is out of 100. And so we want to make sure we're going to the hundredths place with our percentage. We're going to look at problems that involve percents, and let's look at a couple of those. First type might say, what is 56% of 310? Our instructions are to round that answer to the nearest tenth. So what is 56% of 310? We don't do a ton of algebra, and this won't really be very complex algebra, but we are going to introduce a variable because as we look at this, we see what. That's the thing I don't know. So I'm going to call that x. Is. Anybody think of a math word that would be is? Like if I want to make something out of this that's mathematical instead of words, what am I going to use for is? What's a math word that has the same meaning as is? Two things are the same. We would say one is the other. Excellent, Kevin. Thank you very much. Is going to be equals 56%. We're just going to rewrite that as a decimal. When we go to make our equation, what is the thing we don't know? We'll call that x. Is going to be equals 56%. We're going to write as a decimal, which will be 0.56 of. That's a word that tells us to multiply. Of is a word that tells us to multiply. And 310 is just 310. So what we've done here is we've translated something we did quite a bit of in chapter 1. We took words and turned them into an equation that we could solve. In chapter 1, we would often draw a picture as we'd go from words to a picture to an equation. Here, we're just going from words right to the equation. What is the thing we don't know? Is equals 56%. We write as a decimal. Of tells us to multiply. 310 is just 310. And so now what I'm left with here is that x equals 0.56 times 310. Okay, well, we'll just multiply those then. 0.56 times 310 is 173.6. I was told to round to the nearest tenth. Well, this already is. So we're all done here. And our answer is just 173.6. What is 56% of 310? First, we translate it into an equation. And then here we just had to simplify by multiplying. The one at the bottom is a little more challenging than that. Let's take a look. 22 is what percent of 70? So what we need to do here is the same thing we did the last time. We're going to rewrite this as an equation. 22 is just 22. Is what percent? That's the thing I'm looking for. I want to keep in mind when I get to the end of this that I'm looking for a percent. But for right now, it's just the thing I'm looking for. I'll call it x. Of is multiply 70. All right, so 22 equals x times 70. We've been away from math for a little while. We haven't had a class meeting for a little while. So just as a reminder of our algebra here, we're trying to make multiply by 70 go away. I want to get that x by itself. What do I do to make multiply by 70 go away? And if 12 people type the same thing, that's just fine. That's me looking around the room, seeing a whole bunch of people with their hands raised that know the answer. So please don't feel like I wasn't first, so I'm not even going to bother typing. Perfect, Kevin, Destiny, very good. I'm going to divide by 70 on the right because that'll get those to cancel, leaving me the x. If I divide by 70 on the right, I also need to divide by 70 on the left. And when we do this, all that's left over here is the x. And on the other side, we have 22 divided by 70, which is this really long decimal, 0.31428. And that keeps going. And at this point, I'm done with everything I needed to do. I turned my, well, to get to x, I turned my words into an equation that I was able to solve. Now I need to make sure I'm answering the question. And it said 22 is what percent? Right now, my answer is in the form of a decimal. It's supposed to be in the form of a percent. So I need to turn this decimal that I have into a percent. What I have is 0.31428. I need to turn that into a percent. So I need to move the decimal 2 places to the right. And I'll have 31.428%. And now the last thing I'll do is round to the nearest tenth. Anytime we're going to round, we're always going to wait till the very, very end. If we round early, our answer might not be that accurate. So anytime we're going to round, we're not going to do it until we get to we're done. Now we'll round. So rounding this to the nearest tenth, just a reminder, find the tenths place, look 1 space to the right. Since the number there is 4 or lower, we're going to round this down and have 31.4% as our answer. The question was, 22 is what percent of 70? And our answer is 31.4%. That's a little more challenging than the one above. The one above, all we had to do was multiply. Here, we had an equation we had to solve. We had to turn this decimal into a percent, and then we had to round. Are there any questions about what we did there before I have you try one? All right, great. Here goes. 118 is what percent of 275? And then round your answer to the nearest tenth. So try this one. 118 is what percent of 275? And so if you're unsure, what you want to do here is translate those words into an equation that you can solve and make sure you answer with a percent. If you don't see your answer listed, pick the one that's closest to yours. That way, 1, I'll know you worked it out, and 2, I'll know you had enough time to work it out. We'll go another 30 seconds and then do this one together. Okay, let's see where we are. Almost unanimous on this one. That's really good. Terrific work. Okay. If you don't understand where something came from, you let me know. Let's go through it. So the first thing we're going to do is we're going to turn this into an equation. 118 is what percent? That's the thing I'm looking for. And sort of in the back of my mind here, I remember, okay, I'm looking for a percent. So when I get to the end, I want to make sure my answer is in the form of a percent, not a decimal. Of tells us to multiply 275. In order to get that x by itself, I'm going to need to divide by 275 on the right so that those cancel. And if we divide by 275 on the right, we got to divide by 275 on the left. What that leaves me with is just an x on the right. And on the left, I have 118 divided by 275, which is 0.4290909090. Oops. And that keeps going. I've done all my calculating. This is the part where I kind of look back and say, all right, my answer is supposed to be a percent here. So I need to turn this decimal into a percent. So I need to move the decimal point 2 places, and I have 42.909090%. Okay. Last but not least, round to the nearest tenth. So find the tenth place. We'll look one space to the right. Since that's 4 or lower, we'll round this down to 42.9%. And what we're saying here then is that 118 is 42.9% of 275, which kind of makes sense. 118 is a little bit less than half of 275, and that's exactly what this is, a little bit less than half. Are there any questions about that before we go forward and continue working with percents, but kind of in a different way? All right, terrific. What we're going to see in the rest of this section is, problems that give us a situation that we're going to set up an equation for, and then we're going to solve that equation, like this one. Yvonne spends 36% of her income on rent. If her rent is $1,200 a month, what is her monthly income? We want to take this and turn it into an equation we can solve. So 36% of her income is rent. Let's see, 36% of her income is rent. Okay, well, let's rewrite this thing then. 36%, I know I'm going to turn that into a decimal. Of tells me to multiply. Her income, that's what I'm trying to find, is rent. I was told her rent was $1,200. And just like that, we have an equation that we can solve. You might reread the question 3 or 4 times. That's all right. It's no trouble. It's right there. We can just read it as many times as we need to come up with that equation. 36% of her income is rent. So 0.36 times her income equals her rent, which we know to be $1,200. Okay, I'm trying to get this x by itself. I need to get rid of that multiply by 0.36. So I'm going to divide by 0.36 on the left. Those are going to cancel, leaving me x. I'm going to divide by 0.36 on the right. And so now what I have on the left is just x, and on the right, I have 1,200 divided by 0.36, which is 3,333.33333333, and that keeps going. You'll see nowhere in this question did it tell me how to round. On the homework quiz and exams, we're going to try to be really explicit, but something that I want to impress on you for this chapter, when we have a question that deals with money, like this one does, what is her monthly income? When we have a question that deals with money, our default approach to rounding is going to be to round to the nearest cent. Dollars and cents. So we're going to round to the nearest cent. And if you think about cent, well, there's 100 years in a century. There's 100 cents in a dollar. That means we are going to round to the hundredths place. So by default, when the answer is money, we're going to round to the hundreds place. So we'll find the hundreds place. We'll look one space to the right. That number's 4 or lower. So we round this down so that her monthly income is $3,333.33. Let me know if you have questions. The key here is we went from words to an equation that we could solve, and then make sure you're careful when you round. Commissions and tips will also come up. Maria works at a jewelry store and earns a 22% commission for her sales. How much does she earn for selling $1,200 in jewelry? Well, we kind of have to think this one through a little bit. It's not quite as explicit in the last one, but what we can see here is that her commission, and that's always a word that's hard for me to spell, her commission is 22% of her sales. And so here we want to know, how much does she earn? That's what is her commission? What is her commission? That's equal to 22%. We'll write that as a decimal of, and her sales were 1,200. This one, we don't even have to do any algebra to solve it. We just need to multiply 0.22 times 1,200. And we can see that she would earn $264. Again, though, the main idea, we went from this situation to an equation we can solve to an answer for how much commission she would make. And the main ideas still hold. We're going to turn percents into decimals so that we can work with them in the problem. Of is going to tell us to multiply. You have questions on that one before I have you try one that's similar? Okay, very good. Philip and Elizabeth just finished a meal, and the total cost was $48.20. What would the amount be for a 15% tip? I'll set up a poll for this one, and you can tell me if they wanted to tip 15%, how much would that be? These are definitely the types of problems you can expect to see in the book, on the homework, on the quizzes, on exams related to percents. We'll go another 30 seconds and then do this one together. See what we have here. Almost unanimous. That's good. So far today, the polls have gone really well. If you're not answering the polls or you're having trouble with the questions, please don't hesitate to ask questions. Now's the perfect time to clear up any misunderstandings you might be having and get those ironed out. All right, so let's see what we have here. This is They just finished a meal and the cost is $48.20. What would be the amount for a 15% tip? Now, this one's not entirely explicit, but really what we're trying to find out here is what is 15% of $48.20? Because then that would be 15% of the meal is what we're looking for. So it doesn't really say it like it is there in blue, but that's really what we're doing. And that's kind of an important step for you, is to be able to go, you might be able to go straight to the equation, which is excellent. But if you can't, this is a really nice intermediate step. What is this question really asking me for? What it's asking me for is, what is 15% of 48.20? Because that's what I'd like to know. With that in mind, now we can write our equation. What is the thing I'm trying to find? Is 15% written as a decimal of 48.20. And here, there's no algebra to do. I already have x by itself. We just need to multiply on the right-hand side, 0.15 times 48.20. And we see that x is 723. And so the amount of a 15% tip would be $7.23. Are there any questions on that before we look at a little bit different type of question, but same idea is going to carry through the percent problems that we look at. All right. Here we're talking about sales tax. A pair of earbuds cost $24 and the sales tax rate is 8%. What is the total cost of these earbuds? One of the things you're going to hear me say a lot in this chapter is make sure you answer the question that's being asked. And so when we get to the end of this one, we'll kind of look back and make sure we're giving the total cost of the earbuds. For right now, though, the earbuds cost $24 and the sales tax rate is 8%. So the first thing we want to find is how much sales tax are we going to pay here? And the sales tax that we're going to pay is going to be 8% of $24. Well, we know how to do this. I'm going to rewrite 8% as a decimal. Be very careful. Don't put 0.8 because that would be 80%. And nobody wants to pay an 80% sales tax at all. So 8% is 0.08 of is multiply 24. So we'll go ahead and multiply those together. 0.08 times 24 is $1.92. It's really easy at this point to say, okay, I created an equation, I simplified, so $1.92 must be my answer. Careful. What this number represents is the amount of sales tax that we would pay. Instead, what we're supposed to find here is what is the total cost of the earbuds. In our total cost, we've got one more step to do. Our total cost then is to say, well, they were $24. I need to add on that $1.92 of sales tax. So the total cost here is $25.92. If the question says how much sales tax would be paid, $1.92 would be the answer. But if the question says what's the total cost, then our answer is $25.92. I'll say it throughout the chapter. Make sure you answer the question that's being asked. And so my advice is anytime you finish a calculation, go back up and look at the question just one more time and say, what was it asking me for? It was asking me for total cost. So $25.92 is how I want to respond here. Are there questions about that before I have you try one that's similar? Okay, we're doing great today. That's fantastic. This is a section that tends to go really well, which is awesome because I never want anyone to be overly discouraged after the first exam. First exam is a big challenge because you haven't done one of those before. And so it's kind of nice to go into consumer math chapter with a section that tends to go really well for students, kind of get you off on a really strong start for this new chapter. Anyway, A phone sells for $800, but is on sale for 30% off. What is the sale price of the phone? I'll set up a poll for this and let you try it. Remember, if you don't see your answer listed, pick the one that's closest. That way I'll know you've had enough time to work on it. We'll go another, 20 seconds on this one and then talk through it. See what this one says? Oh, split right down the middle. Okay, we better be careful when we answer this one. All right, let's be really deliberate as we go through this one. You make sure you ask questions if you have them. I think I see what the issue is, but you tell me if you see something that doesn't make sense. So phone sells for $800, it's 30% off. What's the sale price of the phone? So 30% off, I guess what we want to find out here, the first thing we want to find out is how much is the discount? And the discount is going to be, well, that's going to be 30% of the $800. So the amount of the discount is 30% of $800, which we're pretty good at this point. I'm going to convert that to a decimal. 0.30 of is multiply 800. We'll multiply those together. 0.3 times 800 is 240. And then I go back and I say, did I answer the question that was being asked? And the question said, what is the sale price? Well, wait a minute now. They're not going to sell me this phone for $240. What they're going to do is the amount of the discount is $240. That's not the price of the phone. The sale price of the phone, make sure you answer the question that's being asked, is going to be, well, it started as an $800 phone. I'm going to subtract that $240 discount, and what they're going to sell me the phone for, the new price of the phone, is $560. It's always important to make sure you're answering the question that's being asked. And so, yes, the amount of the discount is $240, but the sale price, how much are they going to sell it to me for, is $560. Good. Light bulb came on for Matthew, so that's awesome. I'm guessing the same thing is true for everybody else. If not, you can let me know. What we found over here is the amount of discount, but we were asked for the sale price, so we had one more step to do. So we've been talking about percents, and we talked about, how to convert percents to decimals, and then from there, how to solve problems where we had to sort of rewrite it in terms of, using what, is, and of to help us set up our equation that we were going to solve. And then we looked at some situations involving sales tax, commissions, tips, and discounts. We have one more idea that we're going to talk about today, and that is percent increase or decrease. This is driven by a formula, and that formula is this. Okay, there's a lot there. The first thing that happens when you look at this is you're like, what's going on over here? What is this triangle with a percent symbol? And that is the Greek letter delta. And somewhere along the line, the Greek letter delta became the symbol for change. And so essentially what we're looking at here is, by what percent did this thing change? By what percent did it increase or decrease? So what this is percent change is what that is. The way that we're going to find the percent increase or decrease, increase if it went up, decrease if it went down. So just like your logical instincts would tell you, is by using this formula here, that is the ending amount minus the beginning amount over the beginning amount. And that's, sort of a formal way that looks at this as far as what did it used to be and what is it now. Some of my students have sort of pushed me into another way to think of this, if you want to, is thinking of it as the current amount minus the old amount divided by the old amount multiplied by 100. That's just fine. If that's better for you, that's going to be okay. Because essentially we're talking about, what did it used to be? What is it now? What did it used to be? What is it now? To see how something changed from a previous value to a different one. So either one of those, the black one or the blue one, is just fine. And we're going to look at how this is used in an example, and then I'm going to give you a chance to practice one. First, let's look at this example. A television that sold for $950 6 years ago now sells for $600. What is the percent change in price? One of the things that comes up sometimes is, how am I even supposed to know when I'm going to use this? And the beauty is, when you see percent change, when you're being asked for percent change, that's when you know percent change is going to be ending amount minus beginning amount over beginning amount times 100. And so that's how we know. All right, so let's see here. A television that sold for $950 6 years ago now sells for $600. What's the percent change in price? Well, the things that I need to plug in for are the ending amount and the beginning amount. And like I said before, if you prefer current minus old over old, that's absolutely fine if you want to use that formula for percent change. It means the exact same thing. It's just students have told me that this one is sort of easier to keep their head wrapped around. Totally fine. Okay, well, let's throw some numbers in here then. If I want to know the percent change here, that's the current price, which is now is 600, minus the old price, which was 950, divided by, and the only place you might make a mistake in these is what number goes down here, and it's the old price. What did it used to be? We are comparing what's going on now to what did it used to be. So it's the 950 that goes here on the bottom because that's the price that it used to be. That's the thing we're comparing the change to. We're finding the difference between the two on the top and comparing that to the older value on the bottom. When we do this, let's see, 600 minus 950 on top is negative 350 over 950, and we'll divide. When I do that, I get this ugly looking number that is negative 0.36842 105, and that keeps going. And we don't want to forget about this other part of the formula. There's a couple of ways you can think about this. There's this times 100 that's built into the formula, and you know, by all rights, I should have that written down. Times 100 times 100. Sometimes I forget about that part, and I just think, well, I'm after an answer that's a percent. So when I get here to this decimal answer, I'll move the decimal over 2 places. Or you can have that times 100 right there in your formula and do it that way. And that number that's sitting on your calculator, you can multiply by 100. And now we have negative 36.842105. And that keeps going. We've done all the computation we need to do. Last thing we'll do is round, and this says round to the nearest tenth. So I'll find the tenth place, I'll look one space to the right. That's 4 or lower, so we'll round this down to negative 36.8%. We know it's a percent because we're asked for percent change. One thing I want to say about an answer like this one, if we're asked, what is the percent change? Negative 36.8 is our answer. It's important to note, though, if somebody asked you, you know, how did the price change for this TV? You probably wouldn't say negative 36.8%. Instead, conversationally, this answer that we have there would probably be stated as it decreased by 36.8%. So just, you know, if you see an answer written down in your book where it decreased by 36.8% and you're thinking, well, where'd the negative go? Well, the negative is right here in this word decreased. So if it's a positive number, there was an increase. If it's a negative number, then there was a decrease. The answer you would give on a homework or a quiz or exam would be the negative 36.8. But I just want you to know conversationally, we probably wouldn't say negative 36.8. We would say it decreased by 36.8%. Are there questions on that before I have you try one? All right. Keeping up with the newest model phone used to cost $700, but now it costs $950. What is the percent change in price? And then round your answer to the nearest tenth. I'll set up a poll for this one. As soon as you see percent change in the question, that's how you know you're using the formula that is ending amount minus beginning amount, or if you prefer, current minus old. And the key is which number you put on the bottom. And essentially what we're doing in problems like this is saying, what is it now compared to what it used to be? And how big of a change is that? And in these, you'll come up with a decimal answer, and you can either convert that to a percent or use the times 100 that's in the formula. Either one. Don't do both. Do one or the other. Either the times 100 that's in the formula or convert that decimal answer to a percent and then round. Not until you're at the very end do you do any rounding. We can go another 30 seconds, and then we'll talk about this one. If you need more time, you can let me know. All right, let's see where we are on this one. Oh, very strong. Not unanimous, but close. All right, we'll take a look at it. If you have questions, make sure you let me know. So let's see here. I read through the question. Keeping up with the newest model phone used to cost $700, but now it's $950. What is the percent change in price? And when I see percent change, I know that that is ending amount minus beginning amount over beginning amount times 100. Or if you prefer, current minus old divided by old times 100. And when I go to plug this in, what I'll get then is my percent change will be, let's see. All right, the current amount was 950 minus the old amount, which was 700. So it used to cost 700, now it's 950. What I'm looking for here is the difference between those two, which is why we subtract. And divided by the standard, which is what it used to cost. That's the 700. So the 700 goes on the bottom times 100. All right, so now I've got 950 minus 700. That's 250 over 700. That gives me the decimal answer. I'm going to go ahead and multiply by 100 to give me the percent answer. So let's see, 950 minus 700 divided by 700. I get this decimal that is 0.35714. And that keeps going. Then I need to multiply by 100. So we'll do that and have 35.7142. That keeps going. At this point, because we've multiplied by 100, we have our percent. And the last thing we need to do, what we'll do at the very end, is round to the nearest tenth. Find the tenths place, look one space to the right. That's 4 or lower. So we round this down to 35.7%. Because that's a positive number, what we have here is an increase of 35.7% in the price of keeping up with that model phone.